This video is all about a sample problem wherein we add acids and bases. And how are we going to calculate the heat of reaction or enthalpy of reaction for this type of mixing problems? Now let's proceed with the first problem as what is the heat reaction for enthalpy when 60 ml NaOH or sodium hydroxide at 25 degrees Celsius was added to 50 ml of hydrochloric acid at 25 degrees Celsius. After mixing, the final temperature was determined at 45 degrees Celsius. Now let's proceed. We are given with the mass of sodium hydroxide at 60 ml multiplied with the density of the water since this is an aqueous solution, 1 gram per ml. So 60 ml times 1 gram per ml gives us 60 grams. And the mass of the HCl, to determine it, we're going to multiply it with the density of the water since this is an aqueous solution. So 50 ml times 1 gram per ml gives us 50 grams. And the initial temperature for both mixture is 25 degrees Celsius. And after mixing, it heat up to 45 degrees Celsius. So this is an exothermic reaction. So we are going to determine the heat of reaction or heat of enthalpy or Q reaction. Now, this solution proceeds as the heat of reaction is equal to Q reaction as the mass of the mixture. You're going to add the mass of NaOH and HCl, 60 plus 50, okay, grams times the specific heat of the water. We're going to use this specific heat of the water since if we're going to add sodium hydroxide and hydrochloric acid gives us a product of water. So 4.184 joule per gram degree Celsius multiplied with the change in temperature at 45 minus 25 degrees Celsius. Now this gives us the amount of energy for this exothermic reaction at 9,204.8 joule. Now some resources or sources uses negative 9,204.8 joules because it releases heat. Okay, for a negative heat reaction, it is an exothermic reaction. For a positive value for heat of reaction or Q reaction, it is an endothermic reaction wherein it absorbs heat. Okay, now let's proceed with the other example. When 5.03 grams of solid potassium hydroxide are dissolved in 100 ml of distilled water in a coffee cup calorimeter, the temperature of the liquid increases from 23 degrees Celsius to 34.7 degrees Celsius. The density of the water in the temperature ranges average at 0.9969 grams per cubic centimeter. What is the enthalpy of reaction or heat of reaction delta H solution in kilojoules per mole? Okay, so we're going to determine now the enthalpy of this solution or reaction in kilojoules per mole. Assume that the calorimeter absorbs a negligible amounts of heat and because of the large volume of water. The specific heat of the solution is the same as the specific heat of the pure water. Now we are given with the mass of substances, the volume of the solvents at 100 ml, and the initial and final temperatures. Okay, so the initial is 23 degrees Celsius and the final temperature at 34.7 degrees Celsius. For the mass of the substance, we're going to use the mass of solution for the calculation. Okay, so we are required to determine the enthalpy of solution. Now, let's proceed with this solution. The mass of solution now is calculated as wherein the 100 ml of distilled water, we're going to multiply it with the given density at that temperature, average temperature at 0.9969 gram per cubic centimeter or gram per ml. Okay, so 100 ml of water, multiply it with the density at 0.9969 gram per ml. So ml and ml cancels out. This gives us a gram unit. And then we're going to add it with the mass of the substance, which is the potassium hydroxide or KOH at 5.03 grams. Okay. Adding both quantities gives us 104.72 grams. Now the temperature change will be final temperature minus initial temperature. So the final temperature of the mixture is at 34.7 degrees Celsius, and the initial temperature, which is minus, we're going to subtract it with the final temperature. So 34.7 degrees Celsius minus 23 degrees Celsius gives us 11.7 degrees Celsius. Now to get the heat of the calorimeter, which is equal to MCS, or the specific heat of the water, multiply it with the change in temperature. So 104.72 grams as the mass of solution multiplied with the density, I mean the specific heat of the water at 4.184 joule per gram degree Celsius times the change in temperature at 11.7 degrees Celsius. This gives us an answer of 5,130 joules. For the heat of reaction, since this is an exothermic reaction, we're going to use negative calorimeter or loss of heat. Okay, so delta H reaction is equal to negative Q calorimeter, or it is equal to negative 5.13 kilojoules, okay, or 5,130 joules. Now, to determine the enthalpy of this solution, okay, in kilojoules per mole, we're going to divide this with the amount of the mass of the substance, which is the potassium hydroxide. So 5.13 kilojoule per 5.03 grams. Multiply it with the molecular weight of potassium hydroxide, which is at 56.11 grams per mole. Okay. This gives us a final answer of negative 57.2 kilojoule per mole. Now that ends my presentation for this problem. Our next experiment would be heat of combustion.